Hey, Paul, can you do a test again?
Can you hear me now?
I can hear you. It's quite quiet, but let me just turn you all the way up. And I'm just going to ask everybody online if they can also hear.
Testing.
Perfect.
This is a test. Can you hear? Hello. Yeah. Good evening, everyone. Thanks for everyone sitting down. It's brilliant. So, welcome to the first meeting of the year. It's great to see everybody, and also we've got a few people online. So sorry about that. We're just trying to test it out because no one could hear. Glasses off. This is weird. Okay, sorry, we're having a bit of technical issues here. Obviously, I'd like to recognise the traditional owners of the land, of the different lands and countries and places that attendees are attending today, and also like to pay my respects to elders, past, present, and extend the respect to other Indigenous people who may be present here today. Sorry. It's moving here, but not moving up there. Emily. Bear with me for a sec. This never happens. Does anyone know how to use Zoom? Emily? SOS?
Yes,
Come
sorry.
here.
You're all good. We can hear you and I can see your slide.
Yeah, but it's not moving.
Oh,
Frozen.
okay. I'll be there in a second.
Yeah. What? Turn it off and turn it on again. Sorry about this. Just a sec. So it's moving. It's moving here, but not moving here.
Oh gosh.
All I do normally is just press this button.
Did you have another screen just before as well or not? You know how you said you could see two different screens? I might get your good old AV man to come out and have a look.
Who?
The guy from here. Why don't you come out of sharing altogether and then start again?
Stop share?
Yes. All right, and then go back to screen share.
Yeah.
And then pick where you were.
Yeah.
And see if that works.
No, we've got that up there as well.
All right, so let's flick through and see if anything works now.
It's just not moving. Stuck.
Alrighty, let's find your guy. Oh, thank you.
It's
Because
PowerPoint.
quite
This is
clearly,
not a Zoom issue, it's a PowerPoint issue.
Is it?
Yeah. There you go.
There.
oh, thank you, David. Okay, there we are.
Alrighty, we're in action. Thank
I
you.
would like to pretend like that.
Okay. So we'd also like to thank all our affiliate members as well. Thank you very much. We couldn't do it without you. And of course, all our corporate members as well. And finally, all our members that are here. Thanks very much for coming out tonight. And we've also got quite a few people online to thank you. So tonight, you obviously know what we're going to do. We've got Andre. I can't see the screen now. So I've got Andre from Sydney Water, who's going to talk about Hydroloop. And then we've also got Chris Ferguson from Plastic, who's going to give us an update on AS 3500. This is weird. This is awkward. So it's not moving on the. Hello. Hello. There we go. Magic. I'll just back up here. So again, we're just obviously letting everybody know what our communications are and what we've been doing in the last few months since the last meeting in November. And probably the most important ones are the CPD events. They're really well attended. If anyone's got any events or topics that they want us to present on, then please do shout out. I don't know if Max is here. Max is our CPD coordinator, but please do contact Max or Emily or myself, and we'd love to get you guys involved. There's been a few. Sunnyflow, Steve Lentron had their Sydney showroom launch as well, and the last one is the changes for Class 3 and 9C buildings. We'll talk about that in a second, which is going to be interesting. So I've got some notes to read on that. It's not moving. So yes, that's where we're at. Okay. You're a master. It's frozen again. Sorry.
You're right. Oh, I've got my glass. Well, I think you're after, is that in there? Huh? Okay, so I'm going to get you back to that screen. Where is that screen there?
Yeah, that's all we just did. Yeah.
That should be that one.
Yeah,
I think. Unless you want that.
It was fine until we started sharing on Zoom.
Yeah, it's moving up there.
Did that move?
Yeah. This one's moving. Go back up to it.
When I touch this.
Yeah. Yeah. Simplest way. Close it, worry about it.
Okay.
You know where it is.
Yep. What the slideshow?
Yep.
Right. 8, 11, 53, 11.
Then when you
Yeah, that's good.
okay, I think that's it. Should be there.
Yeah. Alrighty, we're back again. Thanks, Darren. Magic. So again, we're just talking about the what Nick put on LinkedIn there, and so just letting everybody know from the 3rd of July 2023 that you must register a design building practitioner under the DBP Act to continue working on Class 3 and 9C buildings in New South Wales, and you also be required to make declarations related to design and building work. And professional engineers must be also registered. So Nick's put that post up on LinkedIn. So do engage with Nick. Nick obviously can't be here tonight. But David Wood is here. I'm sure I've seen him, and David's up to speed on that as well. So if anyone's interested in finding more information, just please contact David, contact Nick, or give us have a word for ourselves. Yeah. That's good. So the reforming building laws in New South Wales, Nick's given me some information. That was a massive email, so I kind of sort of condensed it a little bit. So I just want to read this out word for word what he's given us. But he's just letting us everyone know that the new legislation, informed by the work of the Joint Industry Government and Fire Safety Working Group, continues the implementation of Building Confidence Report with the recommendations with goals of the following: improving safety, accountability, and transparency, ensuring high quality design, construction, and maintenance, and finally, modernising and simplifying New South Wales building legislation. Okay, I'm going to hand you over to Darren, who's been magic helping, and Darren's going to give us a quick update on, very quick update, Darren, on AS 1851. Up you come.
So 1851 is the standard we use to test. So after the fire stuff's been installed, fire equipment, it gets tested to 1851. It's going to be updated, and one of the big drivers for that is that it's now been brought into a requirement by the New South Wales government. The good news is it's not till 2025, so we've got a couple of years to get ready for it. But basically, it's going to require a building owner to now maintain their equipment. I'd suggest the majority of people do it, but it's now going to be legislated. It was driven in part by people like Strata and the Property Council of Australia and people like that, who I think just wanted to say to owners, you've got to do it, or just make it automatic, even though the problem is with that is that there's no opt-out of certain clauses. So at the moment you can opt out of stuff that's not practicable in a building. That is going to be hopefully the updated stuff that's going to happen. I've also put a note in there. We're also getting accreditation of measures being installed in the building. So again, this only relates to the fire measures, but those fire measures will now need to be signed off by a accredited practitioner, which makes sense at the moment. An accredited practitioner or the like needs to do the design of most of the fire safety measures in the building, and we do annual certification on it. So a year after the place has been completed, this one's going to apply to the one that occurs for the occupation certificate. I've got a couple of slides just on what it means, and that's the little piece of the legislation coming out there. So if there's a performance solution, obviously that goes over the top of 1851 to that extent as well. And you've got to keep the records, so people will be able to access those records for a 7-year period. Most likely people like the fire brigade or an insurer, or someone looking at what's going on. And that's the final part of that clause there.
Thank you very much, Darren. Appreciate it. Okay, moving on. So is Fernando here? I don't know if I pronounced his name properly. Here we go. Got the mic here. This one.
Yeah. Have you got a slide on this, or I'll just go off my notes?
I haven't got a slide.
Oh, okay, that's fine. Good evening. My name's Fernando Flex from Renai Commercial. Welcome. Tonight, Nick Soden's asked me to step in and just have a chat about the revised requirements for the location of flue terminals in undercover areas, on balconies and so forth. Nick being one of the members on the standards committee, they've put together this bulletin. I think I've sent this out in a group email to most of you. But if you haven't got it, come and see me at the end of the night, and I'll give you my business card. You can send me an email and I'll send it to you. So basically, as far as the consultants, the main concern here is with the external continuous flow hot water heaters. And the main intent, we've got changes as far as where the appliance needs to be situated and ventilation and so forth. And the intent of the changes was to avoid the risk of nuisance associated with buildup of combustion products. So that was the reason why they've made these changes. Now, the original ruling, when BCA had adopted AS 5601 2004, all other states had to have the gas appliance, if it was on a balcony, the combustion products had to disperse in the direction of the opening. So if you didn't have the two sides open to atmosphere to have the cross ventilation across the flue, you'd have to have the heater disperse within 500 mil of the opening. But New South Wales under 2004 back then, it didn't apply. What we had to do was actually, and most of the time the heater's on the wall, so we had to put a sideways flue diverter and terminate the flue on the edge of the wall or past the covered area or past 20 mil, 25 mil, or whatever it was. So that was 2004. Now, when the BCA adopted 5601 2013, New South Wales then was put in alignment with the other states with the old ruling of the combustion products had to disperse within 500 mil of the opening. So we were in line with all the other states with 2013. Now, with the changes now, with the new gas code, the 2022 version, which supersedes 2013, which will come in on the 31st of March this year. What they've proposed to do, because of the nuisance of these combustion products on balconies and whatnot, and trying to alleviate having that nasty nuisance clause 6.7.5 being thrown at you by either the technical regulator or the customer threatening you with that clause. They've decided that any heater that's on a balcony will have to terminate the flue past the covered area, or if the covered area, the slab is on the front facade wall, past the wall. Now that's regardless whether you've got two sides open to atmosphere, okay? So regardless you've got two sides open to atmosphere, you will still have to terminate that flue past the wall or the covered area. Yep. Now, so where that doesn't apply, if it's for partially or fully covered areas and recesses which are not balconies and which are open on at least two sides, the flue terminal shall be located to ensure a free flow of air across it and conform to requirements of 6.24. So the two sides open to atmosphere will still apply to non-balconies, but if you've got one side open to atmosphere, well then you'll have to terminate, you can still terminate that flue within 500 mil of the opening, but all balconies, regardless whether you've got two sides open to atmosphere, they'll all have to terminate. And with a continuous flow, obviously, if you've got the heater facing the opening, which most of the times you don't, because aesthetically it's not pleasing and the architect is going to kill you, you're going to have a sideways flue diverter on the front outlet of the continuous flow heater. So regardless, you've got two areas, two openings to atmosphere, you'll have to terminate that sideways flue diverter past the covered area or the front wall. So yeah, it's just basically just to, protect the customer, just trying to alleviate those combustion smells on balconies and so forth. What else? Yeah, that's pretty much it. Anyone got any questions you want to ask me while I'm here? No? Okay.
Fantastic. Okay. That's really appreciated.
Okay. Thank you.
Ferdinando also touched upon, what are you going to say?
Nick asked me to just talk. Nick asked me the other day, he goes, just have a small chat about the height of the gas continuous flow heaters and what the requirement is as far as the maximum height that we can put that at. Now, as far as AS 5601, it does stipulate 2.5 meters to the bottom of the unit, and it only applies to appliances in locations other than single residential premises. So that 2.5 rule to the bottom of the heater will apply, but not to single residential premises, which could be a single house, cottage, bungalow, granny flat. It doesn't apply to that. But as far as the manufacturer, we override that clause, because in our installation instructions we stipulate that the maximum height the heater can go is 2.5 meters. Now, it doesn't stipulate 2.5 meters to the bottom, but if you were to take it to the top, it would just mean the heater is lower and at a better serviceable height anyway. So regardless of AS 5601, we overrule that. So, basically, if you are going to install it higher than 2.5 meters, for argument's sake, to the bottom of the heater, then the customer, for warranty purposes, will need to be able to provide some sort of access scaffolding or whatever to be able to service the heater, and that's chargeable if it's over that distance. So yeah, I just wanted to touch on that. Yeah.
Wonderful, thank you.
Right, thanks.
Please put your hands together for Ferdinando. Thank you. This awesome shirt. Alrighty, got another bit to read out. So Paul McDonald couldn't make it tonight, so just bear with me for a sec, but he's got some important messages he wanted to get out to you. So just want to give a quick update on 3500.3. He's got another meeting coming this Thursday. I'll report back probably to the committee, and then we'll announce any outcomes from that in future meetings. But he believes that's a May deadline for this item. He also said that he sent an email to Dean Crowe, and he wants to get the ball rolling again, the trade-based guidelines, and he's hoping to hear back from Dean very soon. But I think what's happened, there's a bit of restructure at Sydney Water, and this has kind of had a little bit of a pushback on that. In addition to this, he believes that all members should be made aware of the following. So he's been speaking to, oh my goodness, how do you pronounce that? John David McQueen about the new trade-based tapping process. What's his name? on the Sydney Water tapping website. The current application page for trade-based is really only good for installation purposes, but not so much for designers, which we already know. And they're looking to clarify some items. The questions asked on the page solely relate to installations. There are no shortcuts to allow you to make the tapping application to then ask questions regarding design items. This tapping page was set up so there are no gaps in the application process, and that all items are known upfront. What they were finding was that when we did inquiries through the tapping process, there ended up being a lot of jobs in the system that they didn't either go ahead or had correct information. And they wanted to remove these items from being entered into the system. And John has suggested that if we do have any questions or want clarifications on any items during the design process, that we email the business customer email address. And he will confirm that and ask any design questions we may have. And we should also be noting that on our documentation that the contractor is responsible for all trade risk applications, as the information that is requested asks the type of plastic traps being installed, the types and sink arresters being installed, and the types of grease arresters being installed, etc. And all this information is what the contractors would have on hand in case. I believe these items may end up on Dean Crow's desk, but we'll see. That's a quick update from Mark McDonald. I'm going to ask Stephen to come up with Stephen here, so earlier. So please welcome Stephen. Stephen's taken over from Rod temporarily, and Steve's going to give an update on education. Thank you.
Good evening. So I wouldn't say I've taken over from Rod. Rod is one that is very active in the education committee. So Rod put his hand up at the end of last year and asked for some help. He's been fighting this fight and pushing this slog for a very long time to get the industry up and running. And the biggest challenge has been for a number of years and still is a lack of teachers. So our biggest message to the industry is we need more help. And if anybody is at all interested in teaching, then feel free to reach out to myself or Rod. We'd be happy to have a chat. My role, I'll be involved in just handling day-to-day inquiries and basic sort of first point of call. In terms of an update, I work for a German company, so I thought I'd give an update with some statistics, which tends to go down well. The diploma course at the moment, we have 30 students that were enrolled earlier last year that are due to finish mid next year. We've just put through another 15 for the Cert 4 prerequisite for the diploma, which will also finish June next year. Come July next year, there'll be a second class run for the diploma. So another 30 or so students will commence July next year. But between now and then, unless we get some additional help or some more teachers, which TAFE is working to achieve, then that'll be the earliest that the next cohort of students will run. There is a waiting list. TAFE are managing the waiting list. We're aware that at the moment there's about 180 people or so on the waiting list. So if we're doing 30 people, then it will be a considerable amount of time before the backlog is cleared. Hence why we need help. Any questions?
Okay, thanks, Stephen. If anyone's got any questions or want to sort of find out more information, please do speak to Stephen or contact Rod as well. Thanks, Ben. Alrighty. So this is a picture that I seen just last week, actually, on International Women's Day. I was walking down Pitt Street, and this was an interesting display in some sort of candle shop or something. I don't know what it was, but I just found it very interesting. I thought it was quite humorous. So it's part of the dodgy flow. So anyone's got any pictures or anything they see on site, please do send them through to us, because it's it's important to send these through. And it also kind of leads on to this magic item here. And I'm going to ask Mr. Matt Lloyd to come up for the next slide. So Matt posted this on LinkedIn. I think it was on, when was it? It was international. It was International Plumbing Day, wasn't it? A World Plumbing Day, yeah, on Friday or Saturday. And so I'll hand it over to Matt.
Thanks, Paul. Yeah, it's kind of thrown on me 5 minutes ago, but anyway, yeah, look, put this up on LinkedIn, and was actually surprised at the response. It's been pretty big. I kind of thought, look, I wonder how many people in the industry remembers dealing with these, possibly even specifying them there, Gary. But yeah, look, certainly everyone to a degree, and it was really interesting to see some of the younger people in the crowd come up and have a bit of a look at it. But Look, I'd like a few people to throw a guess at what they think that weighs, because that was the intent of my questioning on LinkedIn. There has been some close ones, but I can tell you 45 kilos was not sort of anywhere near it. If you remember a 40 kilo bag of sand cement, that was certainly quite heavy, but that's what we were throwing over our shoulders at one point. Look, I sort of came in at the tail end of this. I can't be a champion of this really, but I certainly, you know, remember cracking beers on site, using 9-inch grinders and carrying these around, but PVC was certainly coming in, so the plastic guys will be pretty glad to hear that. But anyone want to have a crack at that? I know someone did tonight and they were pretty close, so whoever that was.
Before anyone guesses, they want to try and lift it,
Yeah.
because they want to come up. Not cheating, it's just testing the weight. That's why it's here. Go on, someone.
We had a 15, did we? That wasn't bad. You're in the ballpark there. I'll read this to you. This came in from David Clark at Hydroflow. This is his memories. They weighed a lot. Memories of unloading truckloads of earthenware fittings from Mackleweight Richmond days, followed by Charmac deliveries of cast iron pipe and fittings, then a truckload of 40 kilo cement bags, all by hand, not a forklift in sight. The blokes then that were my age now didn't go to the gym ever, but were built like Mallee bulls. In the afternoon, the plumbers who had been out on site digging sewers and stormwater trenches by hand would arrive at our door and start drinking beers. Only blue singlets and stubby shorts, not a fluoro vest in sight. Those were the days, simple days, full of big characters. You didn't last long if you were precious. So that was a bit of a scene of what was going on. But look, it was a bit of fun.
He's a winner.
15 kilos in the room is as close as it's going to get, unless anyone wants to go a little bit lower or higher. 18. Anyone else? 15.4. Okay, well, look, it weighed in, and these were the bathroom scales that I threw it on the way out the door. So I did try and keep them as accurate as possible, but it was that 6-inch gully there weighs 17.2. It does have a chip in it, so but that's probably made up by the flecks of cement that was still on top. I will tell you that it is in such a good condition because a friend of mine lived in a house in Mascot, a weatherboard workers cottage, and he used to ring me probably once a year and ask me to, this is about 15 years ago, to bring over my electric eel and try and clear his line, which we would do. That went from about 1 year to 6 monthly to monthly. And I said one day, this has got to come up. I think David Wood said to me tonight that they were all laid up in 6-inch, even though it was, you think about it, it was probably a family of 4 or 5 living in a small weatherboard cottage in Mascot, but still had 6-inch lines. But when we dug it up, the Mascot's full of sand, and these were all so well preserved. All of the joints had washed out, no rings back then. So the sand cement mix had gone, and these were coming out almost as if they'd come off the shelf out of Macquarie, no doubt. But and when I got to the last gully, I said, right, I think there's something I should keep from this job. So I did. So the PVC and glue and primer and everything else was going in, and these were coming out. But yeah, a bit of history there. But I must say, at 17.2 kilograms, anyone want to have a guess at the pounds on that one? Because it would have been pounds, I'm sure. And God knows what a metre or a 2 metre length was. But the gully itself, 17.2 kilos. And I think we had Michael O'Brien. Anyone remember him? TAFE teacher. Yep. He did sent me a post and said that he thought it was 15.2. So for an old tape teacher to a retired tape teacher now to be on the money, I thought he must have lifted a few up in his day, which isn't bad. So, well, happy World Plumbing Day, everyone, and just tried to add a little bit of spice to it. But congratulations to Paul. I think there's a bottle of wine coming your way. Oh, here we go. Paul, if you'd like to come down, we'll get a photo of you holding the gully.
By the way, the HCAA doesn't take any liability for you pulling your back here. Well done, way! Fantastic.
Right.
Thanks, Matt.
Thanks, Paul.
And well done, Paul. Congratulations. It's all about fun. Alrighty, this is a new segment that we're injecting into this just to sort of liven up a little bit. So it's all about innovation and what's happening in the marketplace. So it could be anything that's happening from a manufacturer point of view. It could be something from a consultancy point of view as well. So if anyone's got any suggestions moving forward, we put some feelers out, and we've got 2 people that are going to come up and do 3 to 4 minutes, a little pitch, small pitch. We're running a little bit behind, so I'm going to probably prod them if they're going too long. But if anyone from a consultancy perspective has got anything that they're working on that's a little bit different, what they want to tell the world what's going on. And it's also an opportunity as well, if you've got any graduates or younger people that want to get an opportunity to come up and do a little bit of public speaking, this is the one. So we're going to invite Stephen to come on up, come on down. Yeah, that's good for Stephen again. 3 minutes.
Me again. So Emily and Paul told me that I had between 3 and 4 minutes to present this, and those who know me know that I can waffle on. So this is quite a challenge for me. I'm going to keep it short and sharp, or Paul's going to tackle me off the stage. So for this innovation segment, I'm presenting a new technology that Viga has launched in the market called MegaPress. It is a press fit system for carbon steel or for Gauss steel. So I'm mostly speaking to those in the industry that dabble in fire, although we do predominantly sell it for mechanical services as well. It's simply an alternative joining method to threaded, roll groove, or welded steel pipe. As you can imagine, press fit, it's a hell of a lot quicker. So there's a lot of flexibility that you can have on site in terms of using the jaws nice and quick, and not as cumbersome in terms of labor and bolting, threading, no machinery, etc. We predominantly sell it, as I said, into mech services and fire sprinklers. There's also some applications in shipbuilding, which we get involved in, and potentially we could do hydrant systems, but speak to me about that first. The way the system works, for those who are familiar with press itself, it's the same technology as your 100 mil copper. So we have a stainless steel grip teeth which bite into the pipe itself, and that's what provides you strength as it presses the 2 metals together. There's a sealing element there which is separated by a separation ring to prevent any sharp objects from damaging the seal. We have a full range of fittings from 1/2 inch up to 4 inch elbows, tees, couplings, and the body of the fitting is coated in zinc and nickel for corrosion protection. With all our systems, Viga have leak detection. We call it the Smart Connect feature, but whether it's our copper, plastic, poly, stainless, or now carbon steel, we guarantee that if a contractor fails to crimp the fitting between a pressure range of 100 and 650 kPa, the system will visibly leak, and you're guaranteed not to miss that during your testing phase. It's a thick-walled system, so it is suitable for Schedule 40 mech services following the US standard or the Australian standard 1074 light, medium, heavy-duty pipe. Can be used on Gauss steel, black uncoated, commercially painted, or even rusty steel, so long as you appropriately clean it and prepare it and file it back. And I said I'd be short and sharp. That's the system. I've left some samples over here. If you have any questions, that's me. That's my name, number, LinkedIn profile. Viga's also on LinkedIn, Instagram, social media. So I'd encourage you to like, follow, etc. And any questions, you know where to find me. Thank you very much.
Fantastic, well done. Short, sharp and sweet. So it's not about a sales pitch, it's just to inform everyone what's happening in the market and what's new. So we're going straight on to Scott Morrison. So come up on the stage, Scott. Please welcome Scott, please.
Good evening, ladies.
4 minutes.
4 minutes, fantastic. Get it cracking. All right. Thank you for your opportunity. Welcome to our first seasonal general meeting and dinner. I'd like to get straight into this presentation. Gibber BIM system, building information modeling system. You're all familiar with the Revit system, Autodesk. This system plugs straight in and is operated through the system throughout. It's based from the Swiss system, which allows any region, once you log in, it will give you access to any online catalog, which will give you instant data on the products straight away. I'll run a quick video for you. Keep it quick. So the overview of the system, it's simple, one application. All the data is available on one page for the opening program. It is a click and drop or plug and play system for Autodesk. It has an improved user interface. It's been designed uniquely, so it's very easy to learn whether or not you're new to Revit or whether you're an experienced user. The new functions are, as I mentioned before, it is linked to the regional areas associated to where you're using the product. So you do have access to the international catalog, but it is locally driven as well too. For the building modeling, it's unique to the hydraulics engineers, provides a lot more ease of access to the systems as well. So one of the big advantages with the new system, you actually have a pipe tagging and a pipe mapping function, which I'm probably sure you may have experienced before. It also currently will eradicate any obsolete products that are out there in the market. It will give you the updated versions. So I'll finish on a video which probably will give you a bit better information.
Everyone is talking about BIM. And it's true what they say. The networked digital planning in 3D promises all-round efficiency and excellence. Nonetheless, a huge gap still exists in many cases between theory and practice. We at Gigalit are closing this gap with BIM now. No sometimes somehow, but in fact very much here and now. The complete array of Geberit items for your planning software in accordance with country-specific and market-specific standards, with reduced practical data models and comprehensive meta-information that are available as required. Naturally, in standard formats in international use to ensure easy handling of our data, independent of systems and software. The Gigalit plugin for Autodesk Revit provides you with rapid access to all Gigalit products. This means you have all the essentials close to hand and in compact form, from the simplified model all the way to all of the relevant data once the planning is completed. theoretical and practical, simple and standardized data, useful standardization that is through building smart or intensive exchanges with research and economics institutes. We are on top of the situation. The future happens every day. BIM now.
So just in wrapping up, if you have any further questions, please, I'm here tonight with my colleague. If you have any questions, please come and see us before you go, as time is of the essence. I'm more than happy to come out and show you one-on-one or for your groups as well too. So thank you very much for your time.
Fantastic, John. Thanks, Scott. So again, just to reiterate what I said before, if anyone's interested in doing this, we're going to have probably 2 or 3 at each meeting. So it's an opportunity for all the affiliates to get involved and for our consultants as well. So I'm going to skip. Oh no, we're not having anything to eat. So this is before we have something to eat. This is all about just again, it's for the benefit of the affiliates. And the question that I posed here is, you're passionate about your role because of what? So everyone get up on their feet. All together now. On. And we want everyone to mingle a little bit and just tell them quickly, just in that 30 seconds or a minute, what are you passionate about and why? Keep moving around. Be a lot of passion in the room. Alrighty, we're going to wrap it up there. We want us to go back to their seats. In your own time. Ding ding. Back to your seats, people. Come on. Show must go on, come on. Does anyone want to share? Does anyone want to share what they learned? You walk into the audience and pick on someone random. Especially one of them.
I was just having a chat with Lewis, to be honest.
I'll repeat your story, Lewis.
I don't think I should.
My God. Does anyone want to share? Anybody? Eye contact.
Well, yeah, I was just telling the story about when I first started with Studer. I actually was just about to sign a contract with Kohler, and I had a recruiter ring me up and he said, I've got this role, it's perfect for you, it's in your line, I think you'd be great, I think you'll get the job. Tried to convince me that, you know, that's what I should be doing. And I said to him, well, look, I'm just about to sign a contract with someone else to be a rep. And I said, you're going to have to tell me who it is. You can't just leave me sitting there going, okay, put me in. So he said to me, it's a company called Studer. Here's their website. Go on there and have a look. And I did. He said to me, if you're interested, ring me straight back because they've closed applications, but I think I can get you in. And I went online and I looked on their website, and the first thing I read about was pressure attenuators. And as an ex-plumber myself, I kind of thought to myself, wow, this could be a real game changer for the industry. It's something new, it's something different to what everybody else is doing, and I could see so many advantages. And so I rang the guy back about 5 minutes later and I said, you need to get me a job. In the meantime, I rang Kohler the next day because I was supposed to sign a contract, and they were pestering me saying, you need to sign. And I said, well, look, we're not really interested in the job anymore, if that's okay. Thanks very much, but I'll politely decline. Hoping that I would get the job at Studer because otherwise I was going to be unemployed. I'd have no job. Fortunately, I got the job, and yeah, the rest is history. So my passion has really been Studer, I suppose. That's about it.
Fantastic. Thanks for sharing. I think Matt wants to say something.
No, I just had a quick chat with David Wood, and he was telling me how much he loves being involved with the standards, and every morning he wakes up and he just says, oh my God, thank God I'm in this group of people. So that took up a little bit of our space. So anyway.
I'm on education. Well, I think everybody knows my involvement with getting the diploma happening again. So it was all about education.
Love it. That's welcoming. Okay, we're going to move on. Straight on to Andre. Andre's been coming and give us a little bit of information about Hydraloop. So welcome to the stage, Andre, please.
Thank you. So Hydraloop's a grey water processing device as coined by New South Wales Health. It's brand new, Dutch developed system. Hydraloop's the name of the company as well as the product they produce. First launched in 2020 at the CES, which is a big technology fair in Las Vegas in America held every year. It's where all the startups pitch their new tech, basically, whether it's IT or whatever. This was an unusual left of field, first time in like 40 years that had anything to do with the water industry, pitched at CES. And it won, you know, numerous awards, best startup, best innovation, and so forth. So it got quite a bit of press from that. And that's how City Water found out about it, from the press that ensued from that. And it's certainly how New South Wales Health found out about it. Neil Shaw from Health picked up the water quality analysis that they'd done in Germany to comply with the European grey water equivalent standards. And he very quickly realised that this is a big game changer in the industry. It was a totally novel approach to grey water treatment. And he coined a term, grey water processing device, GPD. And just remember that, it'll come back to it in the presentation later, but that was very clever move of his, because there's no such term in the Australian standards. He recognised that the Australian standards do not consider this approach. So when Sydney Water got interested, first thing, my background, is all in water efficiency. I've spent 25 years at Sydney Water running water efficiency programs and developing water efficiency programs and so forth. So I'm not a plumber, but I obviously interact with plumbers on a regular basis. Some of the programs we run, Waterfix, has employed 60 plumbers now for nearly 20 years, fixing taps, toilet showers and leaks in households. So we actually have a fairly big plumbing business, and we trade, you know, probably $8 or $9 million a year in that Waterfix service. In the first year, I did 127,000 houses in the first 18 months in the middle of the millennium drought. Anyway, so that's my background. But first thing we did was look at our end use study. We've got about 200 houses that are on high frequency metering, so 15-second meter reads. So we can work out the end uses in the house. We get a trace for every shower, every tap use, every basin use. We use Griffith University to put it through an algorithm that can split the trace up and work out what is what in that very complex trace every 15-second reading. And so this spreadsheet up here on the left-hand side of the spreadsheet or the left-hand 3 columns is basically the results from our end use study. So all the end uses in a domestic household, 200 houses. It's been going for about 5 years, so it's pretty robust data, pre and post-COVID. And what Hydraloop does is it's very selective in what it treats. It doesn't try and treat all grey water, which is the first big assumption that we need to dispel when you're talking about grey water treatment in the context of Hydraloop, because it translates through to the way the plumbing is done, obviously, as well. It only treats shower and bath water and the washing machine rinse water. Okay, it treats that, and then it only distributes water to toilets, washing machine wash cycle, and irrigation. So 3 inputs, 3 outputs, that's it. There's technically a 4th input, which could be condensation from dehumidifiers or air conditioning as well, pretty clean water. So what we get is from our model, I added the 2 right-hand columns, and we just put yeses and nos, what can go in, what can come out of the Hydraloop, and we get 2 numbers, 1,100 litres per week inflows and about 1,700 outflows. And so a range, that gives us a range of what the potential demand reductions. And that's not a bad range to be sitting at, 31 to 48% demand reductions on average household water use. It's line ball with what rainwater tanks currently under basics are designed to do. I did the basics modelling back in 2003 and 4, connect the rainwater tank sized appropriately for the postcode's rainfall with an adequate roof area will deliver roughly 40% household demand if it's servicing the toilets and the washing machine in the house. These are all averages, right? So there's always exceptions, but on average. So Hydraloop Sands is positioning itself quite by mistake. They didn't design it for Australian conditions, but it's positioning itself perfectly to compete with rainwater tanks in the Australian building market, which is why I got pretty excited about it, because this thing's the size of a small fridge. Okay, very few moving parts, very unlikely to break down. Fully biological process, no filters, no screens, no chemicals. So it's a bit of a game changer. It's a pretty simple process, and I'll start drilling into exactly what it does. But the first thing for this room is the plumbing is quite different, and we're going to have to slowly change the perspective of how household plumbing is done if they're going to be recycle ready, is the term that Hydraloop have used for equipping a house ready for this to be connected. The shower water, for instance, has to be separated from the floor drain, the toilet, and the basin in the bathroom. Shower and bath shouldn't need to be separate and brought down to the position where the Hydraloop is. Toilets, just like a rainwater tanks, the toilets are supplied by the Hydraloop, not by mains. And there's an irrigation outlets, and I'll get to this, how this works as well, but there's a Hydraloop irrigation path from the Hydraloop as well. So there's 3 outlets. And sorry, and the second one is to a washing machine. It will service the washing machine as well. Underlying feature, and again, this is why Neil Shaw Health distinguished Hydraloop from anything else, is it sits in the home. It utilises the thermal envelope of the home. So the warm shower water and the fact that the houses sit around 20 degrees accelerates the biological process. It's not in a hole in the garden or outside. Therefore, it's designed to have a permanent connection to the sewer. It sits on top of a sewer connection, and it has a backup water supply, which can be rainwater or mains. Water quality is surprisingly good for such a simple system. It's very clear. The process does not remove salts, is its weakness. That's why it's still only a grey water treatment system. It's not a black water, processing or treatment system. It's only going to be ever going to be good for wash machine, wash cycle, toilet flushing, or irrigation. It's full of salt. Biological load is right down to the minimum. But there is going to be a small population, biological population, so you can't just put it back into a rainwater tank and leave it to storage, because eventually that will bloom. The process is there's 2 tanks stacked on top of each other with a central column as well. And there'll be some photos of the Hydraloop later in the presentation, but essentially you've got a total capacity of 300 litres, top tank 180 litres, bottom tank 120 litres. Most of the processing happens in the initial column. There's a lot of screening and aeration that goes on to reactivate the soaps in the detergent, in the wastewater, and that starts a process which is called foam fractionation. So basically, anything that's even quite microscopic, but certainly anything quite large, it actually floats to the top, doesn't settle to the bottom. There's a lot of aeration happening in this central column. And there's just a really simple, non-movable, but just a sloped surface at the top of this funnel, where the inlet funnel, and it's got the bypass to the sewer. So anything that can be carried by an enormous amount of bubbling, there's aeration pumped in at the bottom. It's carried upwards and skimmed off naturally via this mechanical. It's not a moving part. It's just the design of the inlet funnel, basically. So it achieves the bulk of the heavy lifting of the treatment process in that first sort of 20 seconds of wastewater coming into it. And then it flows into the large top tank, where it's just a biological process. There's bioballs sitting in there, and it's aerated again. It's just a little aquarium pump that drives all the air in this unit. Very simple process. And after about 4 hours, the water comes out like the right-hand glass. Pretty impressive. And then after about 4 hours, that top tank then drains down to the bottom tank, 120 litres, meaning there's always a little bit of water left in the top tank to keep the biological activity live. And then that water then, the bottom tank, is available via the internal pump, 24-volt pump, DC positive displacement pump. That'll shift it up to 3 floors up and up to 180 meters horizontally as well, to any toilets and washing machines in the house. It's a domestic system, right? New South Wales Health published Ad Note 7 in response to Neil Shaw's evaluation. It's available on the web. The distinction is that the Hydroloop or grey water processing devices, of which Hydroloop is one, they don't produce biosolids. It's got that direct connection to sewer. So it's inherently fail-safe. It's not an end-of-line system like the old septic tank conversions and so forth. This is in the house, sits on top of a sewer connection. So any failure, catastrophic failure or anything, just goes straight to sewer. And it's got a backup mains supply or rainwater supply. So even if there's a mechanical failure in the bottom tank, main supply will take over. Being Sydney Water, the story is that one of our GMs saw Hydroloop's press after the CES, and I got the task of importing 30 of the units, so a container full of the units, 30 fit in a container. So we have 30 in the country since the middle of the pandemic. Basically, it took about 9 months to get here because of the disrupted shipping. And during that time, we engaged our internal lawyers to do a canvas. What regulations do we have to comply with? Very quickly, we found it cannot comply with any of the existing grey water treatment or processing standards. One of the key terms you have to comply is the lid must be trafficable. This thing sits above ground in a house. There's no way it's going to have a trafficable lid. That's among many other aspects of the existing standard that we can't comply with. Yet the water quality results exceed the requirements of the existing standard. That's really where the rubber hits the road. But we also get pulled up in the Local Government Act in Section 68. So eventually in the future, local governments will be the ultimate regulator, not health or not the EPA in New South Wales. In Victoria, the EPA take carriage of grey water, and in New South Wales, Health take carriage of grey water. So we don't know what the outcome will be in Victoria yet. Something I'm sure you guys are well aware of, but I certainly wasn't when I started this journey, is we had to commence our trial, we had to go, it's not a watermark product, it won't fit into the Australian standards, it's not recognised, there's no pigeonhole for grey water processing devices to fit within the watermark. So we have to go back and reinvent the wheel and start that process from the beginning. Thankfully, the existing 1540 something or other standards for grey water treatment systems was up for its 10-year review, mandatory review anyway. It was 9.5 years old. So I've got myself on that committee, and we're slowly working through updating that standard to allow grey water processing devices. So we went down the path of a performance measure, and we got Gazettal. I'll skip through this. We got the Gazettal on 11th of November, 4th of November last year. So that was like a 9-month journey getting that approved by Fair Trading. Last bit of regulation is in Sydney. Despite AS 3500 saying that if there's a backflow device within the unit that's compatible with the hazard it presents as a medium hazard risk as defined by AS 3500, Hydroloop included a air gap device which is suitable for that hazard. AS 3500 says if that exists within the unit, then you don't need upstream backflow prevention. But Sydney Water says if you've got any grey water processing on site, you need testable backflow RPZ. So this is a bit of an unfortunate policy mismatch with the standards in Sydney Water's area of operation. So it means there's a $300 roughly, sort of annual testing regime that householders will have to put up with until I can convince James to change his policy. This is a couple of photos of the air gap device. The left-hand shot is sort of an overview of the guts of the Hydroloop. This is where the pump is in the bottom left-hand corner, the UV lamp on the top right, the vertical system. The grey pipe across the top is the bypass to sewer. There's also some solenoid valves and so forth you can see in there. And the air pump's kind of stuck in. Oh, actually, the air pump's up the top, and there's a lot of tubing that's distributing air and so forth around the device. But you can see the main point of these photos is the air gap device. The little quirk in the European standard for air gap devices, the air gap's 20 mils, the Australian is 40 mils, and the US is 38.1 imperial equivalent. So of course, that air gap device had to be modelled again, modified, which is happening. So Hydraloop are busy going through the process of getting their air gap device certified under 2845. So we're slowly building the bridges to get it compliant with a future watermark certification. A couple of photos of the inventor. So Arthur Verkaiser and his wife Sabine came out to Australia in October last year. Arthur's a serial entrepreneur. His first big break was when he was in his 20s. He invented a communications device for aircraft that is the last thing if you've got a complete system failure in any aircraft, whether it be a fighter plane or a commercial plane or a Cessna. If you've got complete system failure, his little box is installed in every single plane that's ever flown since the 1960s. Will guide you via radio waves to your nearest airport. That's he's a self-made millionaire because he's the inventor of that. He still produces every single one himself in his own factory, and he gets all the royalties from that. Not a bad gig. So he didn't need to invent Hydraloop. It's the point of all that. He did. It's a bit of a passion project. He saw wasted water as an issue, and this is in rainy Holland, northern Holland. And so it's a very well engineered device. He's an engineer by heart. Very simple design, very impactful in my view. We proceeded down the path of getting some installations underway. None of these have been fully inspected yet or anything. They're not functioning yet. They just got early commissioning stages. We've got some social housing projects. We've got 2 houses in Willoughby, a passive house in Queen's Park. Eventually we'll have 30 installed. Yeah, just some, whoops. Just another couple of take-home messages. You know, the plumbing is atypical. And I'm sure you guys know already, the shower waste is typically combined under the toilet floor with the toilet and the basin and anything else in the bathroom. That needs to be untangled or designed out. One of the aspects of the trial, I've basically split the 30 units half and half. Half will go to developers, to new homes, and the other half I'm reserving for retrofits. So I'm actively trying to find how many housing types Hydraloop can actually be retrofitted into without too much hassle. And it's surprisingly interesting so far. I live in an 1850s terrace and it's before plumbing. And so all the plumbing is outside the building, inherently easy to untangle that plumbing, and I'll be installing a Hydraloop in my place. Any kind of major renovation typically involves bathrooms or kitchens. And so once they're being replumbed, it's relatively easy to sort the plumbing out. One of the more interesting ones was a social housing project in Glebe. This is on Bridge Road, Glebe, just up from Glebe Point Road. This is all done during COVID. If I don't know whether you recall, during the lockdowns, all the homeless men and women were put into hotels to keep them safe off the streets. And as the lockdown started winding back, there was a concerted effort to find homes for all these previously homeless people. And so mental illness, all sorts of issues that caused them to be homeless. This was one of the solutions. So various agencies had bought dilapidated properties, upgraded them, and this building here is 30 units, 30 studio apartments. Used to have communal laundries down in the basements. Part of the renovation of this building was to convert one of the bathrooms in the studio apartments to a laundry bathroom. And so the communal laundries down in the basements were available. And of course, all the drainage used to come down there to that level anyway. And these walk-up units, of which there's roughly 35,000 in Sydney, their slabs are so thin, I'm sure you know this, the plumbing goes straight through and hangs underneath the slabs and just in a duct in the person downstairs bathroom. So you take that duct away and you can untangle the plumbing, separate the showers from everything else. And that's exactly what we did. So this building now has, and what's unfortunate, it's on a bit of a hill. So there was only the basement on half the building under 15 of the units, 15 of the 30 units. So we're only servicing half the unit, unfortunately, but half the building. But we've got 15 units servicing, 4 Hydraloops servicing 15 units, half the building. And again, they're not fully commissioned yet, but they're in place and plumbed in and ready to go. We're still waiting on some final council approvals. This is just some photos of the passive house in Queen's Park. Very complex build, ventilation systems going all over the place. In this case, the Hydraloop was chosen to be installed in the attic. They didn't want it taking up cupboard space downstairs. It's a Federation era house. So, 1900s and 1910s. And so they've got a pump there, wastewater. They've got a little DAB lift pump in their laundry, lifting their shower and washing machine water up to the attic. And it's access on the very left. This is child's bedroom through his wardrobe. There's a little hatch at the back, and that's to an attic space, right? So that's how you get to the Hydraloop. It's the most compact place possible. The Hydraloop stands about 1.1 meters high, and the plumbing really comes in at about 1.2 meters high. So it's designed to fit into a 2.4 meter ceiling, obviously. This ceiling right at the apex of the attic might have been 2.35. It was really tight fit. And yeah, anyway, it was a real challenge, this installation. There's another one in Willoughby, outdoor installation that will be built into a cupboard. I've just shaded it in purple, roughly where it'll be. This was an old 1930s, 1940s house, double brick, but they're replacing both bathrooms, so it's inherently easy to retrofit the plumbing and the laundry. So this will be another retrofit. Yeah, so the treatment process, just to remind you again, this is straight off Hydraloop's website. There's a little bit of sedimentation, so the heaviest particles will obviously fall straight away, but then that initial aeration stage lifts most of it up, and that's the flotation and also dissolved air flotation. So it's activating all the soaps in the wastewater and getting rid of them pretty early on. Within those first few minutes of coming into the Hydraloop, they're going straight down the sewer. So the biological process has got the lightest load possible. And when you think about it, Hydraloop have always chosen the cleanest, biggest volume grey water supplies in the house as well. They're not trying to get kitchen wastewater, or they're not trying to get the basins. They're just getting the high volume, and also the temperature. The warm water is what helps drive the biological process quickly. There's a process called foam fractionation, which is a process really adopted from the pharmaceutical industry. They use, and again, it's relating to foaming, but it's that biological process already breaking down in the first seconds because of the foam, basically. And then the big tanks really are aerobic bioreactors, oxygenated water. There's air going into it all the time via this little aquarium pump, and the bio balls are serrated just like tennis balls, so with a really rough surface area, but they're hard plastic. And the idea is the surface area gives maximum surface area for biological activity to take place. So it's just a warm, highly aerated tank. And of course, biological activity is going to take off. And then at the bottom is a storage tank. Every 4 hours, that storage tank is just cycled through a UV lamp to keep whatever biological activity isn't dead, is suppressed by every 4 hours through that loop. And again, you're only using this water for toilet flushing and irrigation and the washing machine wash cycle. So Hydraloop will be connected to a washing machine, and what it will do is it'll learn the washing machine program. It will supply water, backup water for the rinse cycle, and Hydraloop treated water for the wash cycle. It'll take everything, but it'll discharge the wash cycle, the dirtiest part of the wash. It'll discharge it straight to sewer, but it'll learn the cycle and trap the rinse cycle. So the cleanest part of the wash is what goes into the Hydraloop and is treated. So that way it can service the whole washing machine with a mixture of recycled water and mains, and deal with the treated water it wants to treat, but reject the treated water, the wastewater it doesn't want to treat. So there's very few moving parts, and so I'm a mechanical engineer background, and so that automatically translates to very little points of failure. You've got a small 24-volt DC pump, so even when it does fail, it's only about $90. You've got an aquarium aeration pump, which is about another $90. They've just updated there's a version 2 coming out. The UV lamp is now an LED lamp with a 7-year life. The current one's a filament, so they've got about a 2-year life. That'll be the first expensive thing to fail, about $280. Apart from that, it's a couple of solenoid valves and some tubing. There's not much else that can fail. So pretty simple devices, 2-year maintenance. The other key attributes of Hydraloop is that, and this is really where rainwater tank industry needs to learn, and any other way, offsite or decentralized treatment systems, is it's connected to a home internet. So you get the consumer gets an app we get a view of what they call a Hydroloop device manager, which is a global view of all the units installed. There's about 60 sensors in each Hydroloop. So you can see all the levels, all the flows, any sort of fault diagnostic. Everyone gets alerted to the installing plumber, Hydroloop back in Holland, and in our case, because we're running the trial, Sydney Water will see the status of these units as well. The customer obviously will get a notification, obviously, if there's a failure. Last slide, I think, well, there's always often been a question, what's the energy use? There must be a downside somewhere, and it does use a bit of energy. It's got a UV lamp, obviously, it's got aeration pretty constantly, and it's got a DC pump to pump. So that equates to, and where I've got the data from, and it's not Hydroloop haven't been particularly forthwith with the energy use. I don't think it's something they've considered seriously. But when they did the water quality testing in Germany, it had to go for a 5-week test period, just like the Australian standard requires a 12-month test period to evaluate it over a period of time. During that 5-week test period, and this is a copy of the certificate from the German lab, it used on average 55 kilowatt hours per day. Translate that over a year, it's 200 kilowatt hours for an average household, which is about 11% of household demand. So it's not insignificant, but it's not a major use. And what Hydroloop do talk about is that because it's warm water, the water's kept at about 35, 37 degrees. Water coming in is about 40 degrees from a shower, so that's all reasonable. The water going out for toilet flushing doesn't really matter, but for anything going into the washing machine, for instance, it's basically you're getting a free warm wash with no additional energy required. And anyone that knows anything about the washing machine standards, and you realise that the warmer the water is, the shorter the cycle is, the less detergent you need. So it's one of these virtuous cycles. If you've already got warm water, you're at least going to get a short cycle if you don't put less detergent in. Any questions? That's the end of my presentation. Happy to take any questions if there are. We imported them for about $2.5 grand. So pretty cheap. Installed probably about 5 to 6. Oh, you got to keep running.
So given that cost, how long does it take the return on investment, roughly?
So if
savings taken into account.
Yeah.
I look at it from a solar perspective because, solar's a big thing. A lot of people are pushing batteries, but the return on investment for a battery sometimes is not worth the investment. Yeah. Look, really the game for Hydroloop is to get enough points to make it included in basics and compete with rainwater tanks. Then developers will just choose it because it's pretty much price parity with a rainwater tank, but it's about a 1/5 or a 1/6 of the surface area, and land is worth paying for, as a premium for how little space this takes up on a block. And my guess is that this will be at least twice as reliable as the average rainwater tank installation. Yeah, at the front here. Yeah, so it's in Sydney's mild climate, so different story in the mountains or far western Sydney where they get frosts in winter and so forth. Coastal Sydney, outdoors not really going to be a big issue, but I'm just waiting for the trial participant to emerge in the mountains or somewhere sort of west of Parramatta. It's inevitable that someone's going to ask to install it outside where there's frost, and we're going to have to say it's fine if it's in an insulated cupboard. You've got to. It's only small. It's just half the size of a fridge. All right, it's not a big impost, and obviously the pump, everything runs more efficient if it's close. Just as it's always good to have the wet areas consolidated in a house. So that's where you want the Hydroloop as well. And sorry, the material. Yeah, it's all recycled plastics. The bulk of the unit. Yeah, I don't know what it is exactly, but it's recycled. So. You got the microphone.
Yeah, you mentioned the trafficable lift as an issue for performance solution.
Yeah.
Are there other performance solution requirements, and do you actually have a performance solution for that already? Or?
No. So what we've done, we haven't even attempted to comply with the existing standards, other than the water quality results. The point we're trying to make is really the only thing that's important about the standard is the water quality results. The journey there is kind of irrelevant. So that's really what we're pushing on the committee, is that they need to focus on how you get to that consistently good water quality result. And HydroLoop addresses that. You know, anything that's in the thermal envelope of the house that's largely biological is going to respond fairly consistently. It's the change in temperatures and humidity and so forth that affects these outdoor systems. That's the problem. In a cold winter's night, biological activity is either going to die or be heavily suppressed. So suddenly you've got a 7-hour batch time, not a 4-hour batch time.
Yeah. And the being such a low risk, the check valve, did it really need a such a high level of protection, or?
Well, the definition under AS 3500, we're not going to cause a death, but you could cause illness, right? So it's a medium hazard. So we're stuck in that air gap realm under AS 3500, and I think that's perfectly reasonable. And we've got a reasonable solution by HydroLoop. It's an air gap device. They've got to modify the gap by 20 mil to make it compliant in Australia, which is not rocket science. So we'll get a compliant air gap device under 2845 or whatever, I think that's the name of the standard. But where my bugbear with James Milton and Sydney Water's policy is that it doesn't look at the device, it looks at the property. If beyond the meter, is there grey water in there? Yep, well, you definitely need a RPZD. So that's my problem. Is this grey water processing devices need to be considered differently. They're inherently safe. They overflow to sewer. They've got a air gap device that's compliant and will be registered in time. It can't possibly cause any harm within the home or outside the home.
Are there any attachments, Andre? Because I'm thinking about heat recovery.
What would you want to bolt onto it?
Well, a heat exchanger. You could do heat recovery from the water system. You're storing it and recycling it, and
yeah, but
you use that to preheat shower water. Or
that heat though is important for the treatment process. So heat exchange will take heat away. You want to retain that heat. It's very thick plastic for that reason. It's kind of self-insulating. When you think about it, shower water starts at roughly 45 degrees. Your gut is 37 degrees, and it's taking material from your body from showers. So it's the bacteria load is going to be very similar to a human gut. Same sort of process. Your digestive system takes about 4 hours, half a day to process things. So that's exactly what's going on. And it needs to be that constant temperature, just like mammals have a constant temperature. That's the only way you're going to get that consistent outcome of water quality.
Just a quick one. Have you trialed on non-sewered areas? In other words, areas where there's septic tanks?
Yeah, not yet. So I inherited a list of customers that had applied to HydroLoop in Holland that wanted them. So that's the first 12 customers basically I've got in the trial, and I've only installed 6 so far. So I've got another 6 of those. They're all in various stages of building projects. So I've really only got another 3 or 4 or 5 to recruit beyond that customer list. And there'll be a couple, it'll probably end up being a bit more that I found along the journey. There's been a few that have bailed out for whatever reason. The building's not compatible. There was one that was already connected to recycled water. They didn't even realize it. So there's always people that their aspirations are greater than the reality. So every time someone contacts Sydney Water or HydroLoop and they're in our area of operations, we do an initial sanity check. Is this going to possibly work? But
did you perceive any difficulty with connecting it to a site sewer treatment system?
Yeah, so I don't have any problem with it. In fact, what's more recently, and I haven't changed the slide, I should, but there's if you want to Google it, WOTA is a Japanese competitor, and it's called the Wota Wash and the Wota Box. Japanese, so the terminology doesn't sound brilliant to our ears, but very, very smart little startup. They produce a full blackwater treatment system, and it's probably twice the size of that table. Portable, it sits on wheels, and they've got about 40 of them in Afghanistan. In Turkey for that nasty bloody earthquake, right? The Japanese rescue workers went over there, and it was just to have decentralized treatment systems so people have a shower, a warm shower as well. It heats the water and everything. So they've got 30 of them. That was their first batch of post-prototype production that all went to the disaster site, and they're being used regularly by something like 400 people a week are having showers with these systems. So it's cloud connected, but it's not a biological process. It uses filters. It's basically a mini desal plant. So it does use electricity, but the footprint is amazing. That's for one house. It's the size of a chest freezer. And the water is drinking water quality.
Being a biological system, how does it deal with like extended periods of low or no flow, like if someone goes on holidays? Like that?
Yeah, so it goes into a holiday mode, and it's that same principle that top tank doesn't drain. The top tank's bigger volume than the bottom tank, so there's always about 40 litres that sits in that bottom tank. And what it will do is it'll keep introducing a little bit of more of backup water, fresh water, and dumping a little bit of it. Just a gradual cycle, just to keep the biological activity from going stale. And then you use the householder would use their app to tell them it's going on holidays. It also detects when it's not being used, and it automatically goes into this mode as well. So it has, because it's got backup supply, it uses that to self-flush and self-clean it as well. It's constantly stealing a bit of potable water to clean itself each day. So it's remarkably self-resilient.
Do you need to make any behavioral changes to get maximum efficiency out of the system? Like when you take shower?
Yeah, I mean, I cut a few slides out for this audience, but when I'm normally pitching to customers that are interested in buying the thing. So yeah, those two numbers, the 1,100 litres in and 1,700 litres per week potential demand. There's a big gap there, 500 litres gap. And that's really what comes down to your question, and that's why we're doing a trial, is we need to understand how human behaviours are in these houses. It's the daily cycle. Do we get 3-4 hour cycles, batches in a day, or do we just get 2? That's the big question. The capacity utilisation of it, maximum capacity is 3 12-hour lots during people's awake hours. You want to be able to drain that bottom tank 3 times, and that's 360 litres. Per day potentially, and so that's how you're going to get up to 1,700 litres a week. So it's going to likely, the probability is it will fall somewhere between 31 and 48% demand reduction. I'm really hoping it's up around 40% at least, because that means it's going to sit quite solidly within the basics policy, and then developers will just be choosing this thing, and you guys will be designing systems around it.
Is there a commercial version available?
Well, yeah, so this is the one units we have is H300, the 300 being the 300 litres, and then there's H600, which is just twice as deep. So it is probably the size of a fridge. The H300 is about half the depth of a fridge. So the 600 litre unit obviously is for bigger units, bigger facilities, but as I've shown in the social housing thing, you can bolt 2 of them together. You don't bolt them together, but they flow in a cascade. So once one's full, any surplus flows goes into the other one, and so on. I've seen installations. They did a very large student accommodation in Belgium, and there's 32 of these units in one line. So big, multi-thousand people building, and the whole building's connected up with Hydraloop.
So what's the maintenance? What's the minimum maintenance?
So on a 2-year basis, we don't, I mean, I can only go on Hydraloop's tops. We haven't gone through a maintenance cycle yet. Most likely in the current ones we have that still have the filament UV lamps, that'll be the first thing that fails in 2 years, 2.5 years thereabouts. The Hydraloop will tell you when it fails. They've worked out that these things draw slightly more current in the last 15% of their life. So as soon as there's a current meter on it, as soon as the current meter goes up, you get an alert saying you've got probably 3 more months before it's going to die. So pretty clever. It gives people plenty of warning before there's a complete failure. We've had one failure of a pump. They're tiny little 24-volt positive displacement DC pumps, and the impellers are ceramic impellers, so they're not likely to get damaged, but a bit of grit blocks, just the smallest bit of grit in them can stop the impellers from spinning freely on their little shafts. And so you just got to pull it apart, flush it, and put it back together again. That's happened in one customer's house. So that could be, it's an early inkling of a failure, but this is not a big deal. No, because it self flushes, and because it's warm, those fats don't solidify, provided they flushed off before they stick around for very long. I really can't see a need for it. Maybe in 10 years time, they say in Europe there's a lot of hard water, and so they say every year, and especially in UK, you'd have to flush it with citric acid. It's obviously to dislodge some of the calcium that might build up, but there's no evidence of fats or other more problematic waste products building up in it.
Any more questions?
Sorry? Warmer? No, not yet. That's this process. The performance measure is designed to run the trial, 30 units in the field, and we'll monitor the metering. We'll get the demand reductions. We're individually training every plumber that does it. Sydney Water will have oversight of the performance of each unit, so we'll be looking at the device manager, and we'll share all that data with the standards committee and with the basics team, and that will help inform the standard basically. We already know the water quality results they've already got from compatible well-aligned standards in Europe and in the US, so that there's fairly good alignment between the water quality results across our standards and theirs. So it's not really about the water quality performance, it's about just the practicalities of the standard. It was written more than 20 years ago, when the only solution was retrofits into old septic tanks and so forth. They weren't designed to be in the home and anything like a hydrolysis. This is why I keep saying it's a step change. The standards didn't anticipate this sort of product coming onto the market. And now with this new other device I talked about, WOTA, is another thing. It's designed to be close to the household plumbing. It's a complete off-grid system. They've got, when you go look at their website, they've got several off-grid houses in the hills west of Tokyo that are just running. The only water supply is this WOTA system. No rainwater tank, no nothing. It's just WOTA system, and it's a household of 4 is running off it. And there's like 3 solar panels on the roof, so that's the entire energy for the house and the water treatment system. Pretty amazing. That sort of thing could go in a caravan.
Andre, I think we're going to wrap up there, but
Fair enough.
that was fascinating. Really interesting. We really appreciate you coming out.
No worries.
How do people, if they want to find out more information, how do they get in contact with you?
I've shared my email address, so just contact me. My number and email are on the slides, which will get shared, I guess. I'll just want to save it as a PDF before you send it around, because the photos make it too big. Yeah, just contact me. I've got probably 5 or 6 units. If you've got any good candidates, major renovations where the plumbing can be untangled, so to speak, love to hear from you, particularly. And yeah, as I said, I'm looking for a diverse range of houses. So the only reason why I might reject an otherwise good candidate is if it's exactly the same sort of housing that we've already got. I'm trying to be able to, when I finish this trial, I'll be publishing the results saying, if you've got a house of this type, these are the sorts of things you're going to come across to enable it to be retrofitted, as opposed to it's too hard.
Fantastic. Emily just said she's going to send a presentation round to everyone tomorrow, and I'll include Andre's email address as well, so if anyone's interested can reach out to him direct. So please put your hands together for Andre. Thank you.
Thank you.
All right, we're doing okay for time, so I think we'll have a little bit of 5-minute break so people can just mingle and talk, and then we'll get cracking again. So we'll start again at 8:15.
Oh, it's just like, I was wondering what was behind it. It's just the normal left,
Yeah, yeah.
up and down.
No, left and right.
Oh, I said it right.
Yeah, just press the right button.
Alrighty, it's 8:04. Everyone can take their seats again, please. Well. Chop, go on, we're ready to start again. Alrighty, so pleased to announce that Craig Ferguson is going to give us a really detailed talk, and looking from the slides, it's going to be excellent. So please give a round of applause to Craig from Class Tech.
Yeah, good. All right, well, those of you who were here for the last meeting last year, a geotech colleague of mine, Jason Bauer, gave a presentation about really the characteristics of soils and what determines reactive and unstable soils, which was a pretty informative presentation and a good precursor to get into this new appendix that's gone into AS 3500 Part 2 last year. That appendix is pretty much a section of another standard AS 2870, which has been around for quite some time, and I've been on 2 previous committees trying to get that information brought over into AS 3500. And finally, the last committee that had a crack didn't quite get it into the normative section of the standard. It's as an appendix, but at least there's something in there now. So tonight I'll pretty much focus on what is in that appendix. But just before we get there, I guess just as an introduction, the problems associated from not just a plumbing perspective, but a construction perspective from reactive or soils that move is pretty huge. And this is a good example here. So where I'm from in Queensland, we have a thing called the QBCC there, which is the Queensland Building and Construction Commission, which is obviously the state's watchdog. And when things go wrong there, what the homeowner does is obviously complain to them. And the first thing that happens 9 times out of 10 is they send a camera guy out to camera the drain. So this is when the homeowner complains about things like cracking walls and windows and doors that can't shut, and those usual things that indicate that a structure has moved in some way, shape or form. And I've been working with this one company, Ben Theslow from BT Plumbing. He's been the camera guy for the QBCC for 15 years. And he's provided a great deal of really good data, which has helped us as far as developing products in this field. But this is a block of 13 townhouses on the north side of Brisbane. Construction date was about 2017, and homeowners started making complaints 2 years later. 2019 was when Ben went out there and cameraed this drain. So I'll go through this pretty quickly, but this is his same report that he issues to the QBCC. He always does the stormwater drains first. So downpipes were obviously broken out the front of the building. He then went inside the building, and pretty much every time he cameraed a drain, there was something wrong. As you can see, there's some pretty big separations there. You'll also note in some of his notes there, he says if he finds articulated fittings, meaning swivel joints and expansion joints and those type of things that help risk-proof drains, he's made the note on this particular job that there was no articulation found. There's an ORG there, and that's the mud map he did for the first townhouse. So there was 6 breaks in that one, and I'll just quickly go to the next adjoining townhouse. So these are 3-story townhouses, and same sort of story. You've got the stormwater at the front there with breaks. You've got the stormwater at the backyard on this job with breaks at the base of downpipes, then going inside the house, and there was significant breaks inside as well. And some of these depths are quite deep, 1.1 meters. That's quite deep. So for ground to get that wet, that deep, that's a fair way down. And there's some more breaks. Spanner unit, broken IO. The ORG's got gravel in it. IO surface separated, and there's the next townhouse. So there was 11 more townhouses to do on this lot, and it was the same story every single one. So I need to follow up with him where this was, because obviously it went to court, but at the time he said there's probably only 2 things to do here, which is excavate underneath every slab and to a height that someone can get under there, and obviously replace the plumbing or bulldoze every single townhouse. And Ben's got he's got 12 guys working for him full time now, so this sort of work is keeping him very, very, very busy. So just Appendix G, a little bit about the scope. It applies to residential buildings, which I know isn't our cup of tea here, but realistically a drain's a drain. So whether it's a house or whether it's a medical centre or a childcare or a school, a lot of the plumbing, the way we do the plumbing is exactly the same. So if the soil moves for one drain, it's going to move for another. It doesn't provide designs for P class, and I'll talk about P class. It's for drainage systems up to 225, and it basically has taken, as I said, a lot of what's in AS 2870, which is the footings and foundations code, and has brought it across into the back end of AS 3500. So what is reactive soil or unstable soil? It's basically in Australia, it's predominantly clay, and we're building on more and more reactive clay now than ever before, particularly as we build predominantly more west. So we're getting away from the sandier type soils that drain really well, and we're getting into clays that we used to farm on, and they're great for growing things, not so good for putting slabs on, unfortunately. It's all about also control fill that's been brought offside or taken on. It deals with mining subsidence, and it deals with settlement as well. So Jason explained this last year, but this is his job. He goes out there, his guys go out there before a job's even started, and they take soil samples. It differs from state to state. And back home, each individual block needs to have 2 or 3 soil samples taken, whereas I know in this part of the world, a soil sample can be taken on the whole site. So there might be multiple blocks divided up on that site, but only a handful of soil samples need to be taken, which can not necessarily provide the best information about how reactive that particular site is, whereas in other states, it's more site specific. So generally most boreholes are about 1.5 metres deep, and they take sections out of that. They'll put sections into an oven and they'll cook it, and then they'll obviously add moisture to other sections, and from that, they will arrive at a soil classification. So every decent geotech report will have this in it. And this basically from a plumbing perspective is what we really need to know, because we need to know what we're dealing with when we're laying a drain. A, S and M are pretty good, as you can see. Appendix G really refers to everything from H1 onwards. So 40 to 60 mil movement, H2 60 to 75, and E is 75 mil plus. H used to be one category. A few years ago, they separated it into two, which I wish they would have done with E, because E is 75 mil plus. And to give you an example, I had a plumber call me not too long back, and his geotech report said he was working in ground that was going to move 200 mil. So you wouldn't be. It's funny, they can make slabs to withstand that sort of movement, but our PVC plumbing systems really can't. So E should have been pretty much put into the same thing where it was E1 and E2. Maybe E might have gone up to 150 mil, and then there was E2, which would have been an open-ended category. Just on P-class sites, anyone who comes across Ps, they tend to panic and they tend to think that P means problem. It really doesn't. There's only a small percentage of P-class sites that are really a problem from a plumbing perspective. Really just stick with what the soil classifications say, because it's as simple as this. Most sites are classified P because there's a tree on that site. So how many sites would have a tree on it? A lot of them. How many sites would have maybe an old shed or something that's going to be taken off that site? How many sites are going to have fill brought on or taken off that site? So all those sort of things will characterise that site as a P-class site. It doesn't tell you necessarily how much the ground's going to move. So generally with P-class site, ignore it. Somewhere else in the geotech report, it will go on to say exactly how much that ground is going to move. So it's all about moisture at the end of the day, because it doesn't matter what the classification of the ground is. Like I said, that site that was going to was characterised 200 mil movement. If it doesn't get wet, it's not going to move. It only moves when it gets wet, and then obviously reverse to that, it moves when it has to dry out as well. But if there's no moisture in the ground, you're not going to get the movement. So that's important. They want to avoid things like this. A trench that's been left open overnight, it's filled up with water. So right now there's just moisture wicking underneath that slab. If that was a H1, H2E class site, you wouldn't want to be the homeowner of that slab, having water getting inundated underneath it. Same around the site itself. And this is where builders need to be more vigilant in keeping the site dry. He knows he's on a H2 or E class site. So it's all about keeping moisture away from the edges of the slab, because that will get under the edges. Where's most of our plumbing located, particularly in residential jobs, right on the edges. So Appendix G starts to talk about clay plugs. And I'm not sure if many of you have heard about clay plugs, but they have been around in other standards for quite some time. They're referring to a product called bentonite clay. Bentonite clay is used in many other industries in Australia, mining and agriculture being the two biggest. But it's extremely effective at ensuring that moisture doesn't pass from point A through to point B. If you were to have a glass here and fill it up half full of bentonite clay and then pour water on top of it, you'd come back tomorrow and the water would still be sitting there. So it's extremely effective at doing what they wanted to do here, which they've asked for you to basically build a dam wall right at the edge of the slab. So this is for typically slabs like those waffle or floating type slabs, where your pipework isn't not exiting through a footing, it's just exiting through open ground. And you're coming through an area where the ground will predominantly stay dry underneath the slab, and you're coming into open ground that's going to be affected by rain. And they want to basically have a dam wall there. They also say you can use concrete, so you can form up a concrete wall, and you can also use plastic as well. But I mean, what we see out in the industry is bentonite clay being used, simply because from a plumber's perspective, it's easier than forming and pouring concrete and doing things like that, or keying duct taping plastic to around pipework that's penetrating it. And it also asks for a 1.5 metre horizontal layer to be laid somewhere between the top of the ground and where the trench is. But to be honest, if there was a driveway getting poured over that, or a pathway or something else, really that's effectively doing the same thing. So you wouldn't really need to do it. You would need to do it at the face of the trench. So it's there to stop the bed, the plumber's bed, which is the sand and gravel being used as a place where, when water does seep down through the natural earth into that, it can then be wicked underneath the slab. So this is how it looks in practice. Generally, they use cardboard boxes. Back in the day, they used to just bring in a trailer load of bentonite and just pour it in around the area where the edge of the slab is. Now they're being a bit more neater about things and obviously saving money and forming up cardboard boxes, pouring the product in wet, not wet, dry. It doesn't need to be wetted down, which is a question we get asked a lot. You can just go in dry because it's going to get wet once it does rain. But the main thing is once that trench is backfilled, the product is there where it needs to be. And then you can see the articulated joints that they've used immediately on the other side of where the slab's going to be. And there's your horizontal pieces going across the top, 1.5 metres. Appendix G doesn't mention the top of the drain, but it's just common sense if you're using it where your pipework exits the slab. At the bottom of the drain, why not put it at the top of the drain as well? A good example of how effective bentonite is, this is probably the biggest bentonite plug in the Southern Hemisphere, which is the Newcastle Steelworks job. They weren't sure what to do with this after removing the old steelworks from that site. It had been there a long time and they were worried about contaminants leaching out into the Hunter River, and they were going to actually concrete cap this job. Instead, they opted to use bentonite clay instead, in a similar way that we use it in plumbing. But it's a big one. They went down as low as up to almost 50 metres down. The whole length of the wall is 1.5k, and it's not even a metre wide, the wall itself. But as you can see, they've gone down and they've gone across. I've not been to that site, but I've been told they've now put parklands or something over the top of that for the public to use, and that there's monitoring stations out in the river, and they reckon that the results are proving to be very, very good. So that's a big example of what Appendix G talks about using in plumbing. So when you hear the term flexible joints or articulation, primarily this is what those terms refer to. They're talking about joints that can move or provide movement in every possible direction. So when you looked at the classifications at the start there, so say you had a H2 site and you know you need to get maximum 60 mil of movement, you've got to ensure that these joints that you use will obviously provide 60 mil of movement. So that's it. They've all got to have an internal stop. So in the old days with things like expander joints, the old expander joints used to pull out. So when they've reached their full travel, they'd actually come all the way out, which was no good for use underground. Obviously great for stack work, but not good for plumbing underground. So the standard got changed and all these things need to be made with an internal stop. So articulation is what Appendix G calls for and where they want it, and this is probably the most important part of where articulation needs to be installed. And remember, we're only referring to H1, H2 and E-class sites, not every single job, is within the first metre of where pipework exits from underneath the slab. So they want to see two what we call combination joints, providing swivel movement and also expansion movement. And that's, I'll show the picture of that a little bit further on. And the other thing is going through footing. So when you pass through a footing instead of just through open ground, they want 20 mil thick polyethylene lagging for H1 and 40 mil thick for H2 and E-class sites. So Appendix G has this diagram in it, which shows you combination joints coming out at the exit point from underneath the slab. Probably the big change that caught us all by surprise is now they show expansion joints on all vertical rises underneath slabs. So it was something that really was never called for unless an engineer, for whatever reason, specified that they wanted to have movement on all vertical rises. But I think there's so many jobs that are going south right now because of moisture getting underneath slabs that it's led to them to want to have movement now in plumbing systems underneath slabs. So expansion joints to accommodate the vertical movement. And when we think about when clay gets wet, it swells, so it goes up, and that's why they want to protect everything going vertically, and vice versa. When it dries out, it shrinks. So it either goes up or down. And that's in practice how they generally look. These products are put on the verticals. Risers put on above the disconnection trap and four-way riser, and below things like pans and at bases of stacks as well. And this is the second detail in the appendix, which goes one step further. So as you can see, we can't really read up the top there, but this is for E-class sites. So the previous detail was just for H1 and H2 classification sites. So this is for E. So this is 75 mil movement or more. And this has caused a little bit of debate in the industry regarding this, because now they're asking for not just the expansion on your vertical risers, they also want deflective or angular movement built in as well. And I can understand that on certain jobs, you know, if you might be on a sloping block where you're going to get creep over many years or instances like that. But generally on a clay site, you're going to get upwards and downwards movement. So I'm not too sure really why they want to include deflective movement in that particular area there. It also talks about graded risers, so they want to protect graded risers as well as vertical risers. So any branches, they want to see things like expansion joints put on to protect from any movement. Tanks, common sense with tanks. Tanks are always going to move, particularly when you first put them in or when they're empty or when they're full, depending on what type of tank they are. But flexible connections or articulated joints on the inlet and outlets of tanks are just pretty much common sense, whether you're in reactive or unstable ground or not. And a lot of people forget about stormwater when it comes to this, but Appendix G specifically talks about stormwater as well. And it's often a knock-on effect because your downpipes are often your first to go because they're outside, so they're in the weather, they're in the ground that's actually moving all the time from season to season, from wet to dry. So we often see getting the hurry up back there. We often see downpipes break first, and of course, once a downpipe breaks, more and more moisture is in that area, close to the edge of the slab, makes its way under the slab, goes to the next available pipe, breaks it, and then it's just a domino effect, similar to what we saw with those townhouses. Talked about water around the edges of the slab. It talks about drain coil and Stormflex, those flexible type products that are available to try and take water away. They've asked for those to be used 1.5 metres away from edges of slabs, and that's because if you're in a clay site and the clay starts moving, it tends to squash those things pretty quickly, and it just leads to more problems. So they don't want to see that flexible type of pipe anywhere near a slab. Pretty much common sense. And over the years now, we run all of our overflows from hot water systems and air conditioners into waste now, instead of having that dripping down on the ground beside where that unit was. So that's all changed. But the biggest problem out there is the homeowner themselves. So when Mrs. Jones buys her house and she gets the keys, she's not told that she knows she's paid a bit more for the slab probably, but she's not really told why. And therefore, you know, homeowners do all the wrong things. They plant lawns and gardens right up to the edge and put irrigation systems there and pump a lot of water around the edges of their homes. They build retaining walls where they shouldn't, and they don't provide the necessary drainage that retaining walls need. And all of a sudden, you've got a corner of the house that is lifting up because of swelling, and they plant trees far too close to the edges of slabs. Even maintenance plumbers need to be mindful when they do a repair. They don't know what the classification of the ground is, but they'll come along and they'll put a cheap plumb quick on instead of doing something a little bit more substantial, and then within a year it rains and you're back to square one. These products are also available in HDPE as well. Not that you really need it so much for HDPE, to be honest. HDPE compared to PVC are two completely different materials, and they handle the stress of ground movement really well. Most drains in Europe are done in some form of PE or HDPE, and they have a lot of clay there as well, but they don't have the same problems that we have here. So it's a really good material for handling the stress movement. Just quickly on what's happening here in New South Wales, and to compare it to, I guess, where I'm from, when a plumber does a job there now, he has to fill this form out, which acknowledges that he needs to get the geotech report, and he needs to find out what the classification is, tick that box, and then he needs to provide an associated design to provide the necessary movement. So he needs to show that he's going to accommodate whatever movement of that site is by putting articulated fittings in or flexible joints. And I guess the big difference here, and this is why it works, that information then goes to whatever local council is there, and the council inspector who inspects every single drain is inspected in Queensland. So he knows before he goes out there that he's got a H2 class site, and he's seen the detail that's been submitted,
and he'll walk around and ensure that the plumber has put all the necessary fixtures in to risk-proof that job. New South Wales is starting to catch up with regards to that. So now Fair Trading released this just recently, which it acknowledges that acknowledges AS 2870 and the use of flexible joints for drains in H1, H2 and E-class sites. It points out that Appendix G is only informative and not mandatory. So as a result of that, it's just led to them requiring plumbers working in these types of sites here to submit a performance solution, which obviously is an added cost as far as the build is concerned, because not only having to use these fittings, which cost money, but you've got to put in a performance solution for them as well. I know that the HCAA has got a really good template to be used, and there's another very good one from a company called Building and Legal Solutions. So there is a way out of this. I was going to talk about seismic stuff because that's sort of an area that we're getting into now. We're getting more and more questions about seismic design here in Australia. We've been working a lot in New Zealand with regards to that, but I'm getting the wind up now, so I might save seismic for a different time. Yes, thumbs up. Cool. Questions?
The articulated fittings, should they be installed in a pit outside the building or just pair it with everything else that's there?
Buried with everything else that's there.
Anything else? So almost the question, come on.
Silence is golden.
Mine's maybe to you and everyone else. So when we do a P, so I've got a site in Newcastle, better specified P. I've dealt with you about it.
Yep.
As a designer, what do we do? Like, is it you spec hanging straps from and refer to structural, or what's the
in your area? Every job's going to be P, I think. Is that the mine subsidence one?
This was the one in Tyers Hill, Stevens Group. I'm not sure if you remember.
Yes. Yep.
A month ago, I spoke to you.
Yeah, tying to the slab. Yeah. It is a method. It's a method that's brought depending on what the geotech report says. So if you think to yourself, everything's tied to the slab, so it's going to move up and down with the slab. If you've got a block, for example, that's maybe half the slab sitting half on natural ground and half on fill. So if you imagine plumbing is running through that, and say everything gets wet underneath that slab, and that fill is class M, very little to no movement. The pipe work that's in natural ground, it might be class E or something quite severe like that. So that's where the strapping can easily fail, because you've got heavy movement in one area on this slab against minimal movement. Whereas if you can picture it, everything strap should move up and down as the whole slab moves up and down, which in a typical settlement type situation is really good. But if it's a mixed situation like that, it's not so good.
So then so this site in particular, I've got 2 of the pads were H2 and then the other 2 P, and that's confirmed by the environmental scientist.
The piece should still have a soil classification by law. So they've given it this broad brush P, which could mean many different things, but the soil test should have then told you exactly how much that ground's going to move. So if it does say H2, realistically from a design perspective, you really work to H2. You don't need to worry about the P.
Because originally it was P, and then after our conversation, I went back and he knocked it from E to then H2, but then the other 2 are still P, so I'm still fine.
I don't know how you can go doing a soil test and you arrive at E, and all of a sudden you can change it to H2.
Remediation, not necessarily like a site, so I'm guessing it's something to do with that.
Yeah.
I'm not an environmental scientist.
Sounds like you guys need to have a conversation.
Look, just on our geotech reports, I've seen many of them, and they can differ dramatically, and they can often tell whatever story the developer wants them to tell in a lot of ways.
Just the 2 townhouses that you showed at the start.
Yeah.
What was the soil classification?
I don't know, and we don't know. Yeah. And I dare say that form that the Queensland plumbers now must fill out, that came in after that job, for example. So that's where guys were getting away with things and saving themselves and the builder a lot of money. So it might have been a H2 class site, and it would have been up there because that movement was quite severe to cause that sort of damage. So it would have been something like that, whether he didn't put any in, and that's what's happened. So.
All right, we're going to wrap it up there. That was amazing. That's really interesting, and it sounds like you could do like lots of modules. You're a really fascinating person to speak to, and I think everyone will agree that it's really, really interesting, and you're obviously really passionate about what you do. That's fascinating. So thank you very much. So please put hands together. All right, we're really there. Emily's away to draw the lucky door prize. Da-da-da-da.
Sorry, I'm not that many people here. 101. Oh. Oh. Look at what you did. William.
I think Rod's gone, so let's go for higher or lower. Higher or lower than 15, what do you reckon? No, don't throw it down. No. Should we go higher or lower? Lower, all right. Or what did you say, 15?
Yep.
That.
Glasses.
Bobby Park.
Emily.
Up you come. Hey! Big round of applause.
I'll just be here for 5 more minutes.
There you go. Congratulations. Well done. Happy days. All righty. Oh, there we go. Lucky door prize. So just before we wrap up, just wanted to say, obviously we're here for you, and this signage, we are the voice of your industry, yeah? And so it's really important that you get involved, and we really want to get your feedback. We want to listen to you, and this is a quick opportunity for anyone who's got any feedback, or anyone who wants to make suggestions or have your voice. How's it going? I mean, I was speaking to a few people after through the breaks, and they were saying they really enjoy the technical input, and the technical discussions we have are fabulous. And we actually get a lot of people interstate who are very sort of how can I put it, not jealous, but interested in how we're doing this format. And so we're always looking to try and improve it. And so really want to hear what you've got to say. This is your minute to talk. So has anyone got any suggestions or any feedback? Oh, there must be someone. Because otherwise I'll just pick on someone. Looking right at you, Rodney. No suggestions? No? Well, I mean, what about, has anyone got any suggestions along the lines of how we can make it more interactive and like, I mean, we're trying to do that, and also look at, a lot of people are members here. We should probably try and sort of look at, should we be doing like sort of organization membership perhaps, where you get a cheaper deal, and it's like you get maybe 5, a deal for 5 people who can join from your organization. That sort of thing, that's what we're looking for. But if no one's got anything to say, that's fine. Going, gone. Oh, Emily's got something to say.
David, yes. So David mentioned on his way in that he's got some newer members of his team who he didn't know whether or not he could invite along tonight, or whether or not there's space for them. If you do have anybody who's new to your team, then please email me, like message me before one of the meetings. Let me know who you've got. If we've got gaps on tables, they're more than welcome to come along so that they get an idea of who we are, what we do, what happens at our meetings, and the benefits that they get from being a member as well. So That's my 2 cents.
That's a good point. So if anyone's interested in inviting anyone from their organization, from the company, then please do. We can do some tasters for sure. That's great suggestion. Well done. So all I just wanted to say is thank you for everyone for coming. Obviously, there's a few manufacturers here who've got some goodie bags over the corner here. They've also got some stands. If anyone wants to do any stands in the future, please reach out to Emily or myself or anyone in the committee. And just want to say thank you. So thank you. Please mingle, and we're still here till for another 10-15 minutes. So, oh, and we've got some magazines here as well. So if anyone wants any magazines, please take some. Thank you. Well done.
I'll let you know. I can turn it.